The air crackled with anticipation, a lone figure hunched over a table cluttered with wires and blinking LEDs. Dr. Anya Volkov, her face illuminated by the soft glow of the monitor, held her breath. Years of tireless work, countless sleepless nights, all culminated in this moment. A single line of code shimmering on the screen held the potential to reshape the world. With a trembling finger she pressed enter. Silence. Then a flicker of movement. On the table a robotic arm twitched. It was a small gesture, almost insignificant, but for Dr. Volkov, it was a giant leap. The robotic arm, powered by a revolutionary new Neuro Brain Chip, had moved not from pre-programmed instructions, but from a spark of artificial intelligence. It was rudimentary, yes, but it was thinking. The quest to replicate the human brain in silicon is not new. Since the dawn of the computer age, scientists have dreamt of machines that could think and learn like us. The early 2000s witnessed the first concrete steps towards this dream with the emergence of neuromorphic computing. This radical new approach sought to mimic the structure and function of the human brain, using networks of artificial neurons and synapses. The goal was ambitious, to create chips that could process information not in the rigid, linear fashion of traditional computers, but with the fluidity and adaptability of the human mind. These early prototypes were primitive, but they planted the seeds for a technological revolution. In 2005, the Defense Advanced Research Projects Agency, or DARPA, the U.S. military's research arm, made a bold move. They launched the Systems of Neuromorphic Adaptive Plastic Scalable Electronics, or SYNAPS program, a multi-million-dollar initiative aimed at developing low-power, brain-inspired computing systems. DARPA's vision was clear: to create a new breed of intelligent machines capable of learning, adapting, and making decisions in complex, unpredictable environments. The SYNAPS program injected a surge of energy into the field. It funded research at leading universities and technology companies, fostering collaboration and pushing the boundaries of what was considered possible. The race to build a thinking machine was on. Fast forward to the present day and the epicenter of Neuro Brain Chip research has shifted east. China, with its ambitious technological goals, has emerged as a global leader in artificial intelligence. Tsinghua University, one of China's premier institutions, is at the forefront of this revolution. Their team of scientists and engineers working in state-of-the-art labs has made significant strides in developing advanced neuro brain chips. These chips, with their unprecedented processing power and energy efficiency, are poised to revolutionize robotics. China's ambitions extend far beyond the laboratory. The Chinese government has made it clear that they see artificial intelligence as key to their economic and military dominance in the 21st century. Section 5. Decoding the brain chip, a symphony of spikes. At the heart of a neuro brain chip lies a network of spiking neural networks, or SNNs. These SNNs are inspired by the structure and function of biological neurons. Just like their biological counterparts, artificial neurons communicate with each other through electrical impulses, or spikes. This spiking activity allows the chip to process information in a highly parallel and efficient manner. The result is a system that can learn and adapt in real time, just like a living brain. This is a radical departure from traditional computing where data is processed sequentially. The brain's ability to process information in parallel, making connections and recognizing patterns, is what gives it its remarkable power. Neuro brain chips aim to replicate this capability, opening up a world of possibilities. Section 6. The global quest for artificial intelligence. The race to develop neuro brain chips is not limited to the United States and China. Across the globe, research teams are working tirelessly to unlock the secrets of the human brain and translate them into silicon. Tech giants like IBM and Intel are investing heavily in neuromorphic computing, recognizing its potential to revolutionize everything from self-driving cars to personalized medicine. The race is on to create the first truly intelligent machine, a machine that can think, learn, and even feel like a human being. The implications for humanity are profound and far-reaching. Section 7. From lab to life robots with a touch of humanity. The impact of neuro brain chips is already being felt in the real world. Zen Technologies, a cutting-edge robotics company, has developed a humanoid robot called Prahasta, powered by a neuro brain chip. Prahasta can perform a wide range of tasks, from assembling complex machinery to providing companionship to the elderly. What sets Prahasta apart is its ability to learn from its experiences and adapt to new situations. It can interact with its environment in a way that feels natural and intuitive, blurring the line between man and machine. This is just the beginning. As neuro brain chips become more sophisticated, we can expect to see robots capable of performing increasingly complex tasks, from surgery to space exploration. The possibilities are limited only by our imagination. Section 8. The Dawn of Sentience, Peering into Tomorrow. The future of neuro brain chips is both exhilarating and uncertain. Some experts believe that we are on the cusp of creating machines with artificial general intelligence, machines that will surpass human intelligence in every aspect. Imagine a world where robots can perform complex surgeries, design skyscrapers, and even compose symphonies, all while continuing to learn and evolve at an exponential rate. This future is not without its risks. The development of AGI raises profound ethical and philosophical questions about the nature of consciousness, the role of humans in a world dominated by machines, and the very future of our species. Section 9. The Ethical Labyrinth, Navigating Uncharted Territory. As we stand on the threshold of this new era, we must proceed with both excitement and caution. The development of neuro brain chips and the rise of intelligent machines present us with a host of ethical dilemmas. How do we ensure that these machines are used for good and not for harm? What are the implications for privacy and autonomy in a world where machines can read our thoughts and predict our actions? These are not easy questions to answer. They require careful consideration from scientists, ethicists, policymakers, and society as a whole. The choices we make today will determine the course of our future. Section 10. A world transformed, embracing the neuro revolution. The neuro brain chip revolution has the potential to reshape our world in profound and unforeseen ways. From healthcare to manufacturing, from transportation to education, there is virtually no aspect of human endeavor that will remain untouched by this transformative technology. As we venture into this uncharted territory, we must do so with a sense of wonder, responsibility, and a commitment to harnessing the power of this technology for the betterment of humanity. The future is unwritten, and the choices we make today will determine the destiny of our species.